Thank you very much. It's my pleasure to present to you some of my calculations that I have made using the program LS-DYNA and the methodology that was developed together with the consortium and members of this consortium you see on the slide. They are most of the jet engine companies, FAA, Boeing, and about 10 years ago, the members of this consortium decided that it is critical for investigations and for analysis to make sure that we can present the behavior, physical behavior of materials at the high energy impact in order to design or analyze high energy impact effects. Using this technology, for example, NASA analyzed the problem of shuttle disintegration, shuttle Columbia, in 2001. We, using this technology, found that the part of the material that was separated from the tank of the shuttle at the takeoff hit the wing of the Columbia shuttle, and based on the analysis and simulations that I'm going to show you, the same technology, the same methodology, we found that that material was able to break the carbon-carbon composite wing and create the opening for the hot gases, so at the re-entry, this shuttle basically melted down internal structure of the wings and disintegrated in presence of the whole world. Using the same methodology, I asked question number one: is it possible that the airplane Tu-154M lost the left part of the wing that was presumed by the committees on the bench? So, in order to analyze this event, I have to apply so-called parametric analysis. I'm not going to present you all the technical sides because I assume that you may not be interested in the technical side, but I just want to point out that we investigated this from different angles, different velocity, different orientation. I made different dimensions for the birch, since it was mentioned the diameter may be somewhere between 30 and 40 centimeters. So I assumed 44 to make it bigger. I assumed density of the material to be 550 kilogram per meter cube. But I was pointed out from my colleagues from Poland that maybe that birch in Russia is stronger. So I had to use stronger material. And therefore, I assume 850, they were not satisfied enough. They said in Smoleńsk it is even stronger than that. So I put 1,000 kilogram per meter cube, which basically makes that wood sinking in the water. This is why they start calling this panzer birch. I use material properties and mathematical description of the material developed in this consortium with NASA, I built up the model of the airplane using the information available on the internet. I presented my work for the Polish committee first in September 8th, then repeated in November 25th. And I welcomed colleagues from Poland or from the committees to present their work. At that moment, I didn't know that they didn't do any calculations, that all they did was basically sit down around the table, they did what has happened 5 minutes after the crash, and then they just use propaganda method to enforce this notion, this information throughout the world. Well, I am a scientist, so I assume that we have to rely on something realistic, either observation of the elements from the crash under the microscope, using other rigorous techniques, not having access to any of those information, because as you know, the Russian Federation do not allow any international scientists to have access to the debris of the airplane. Even bodies of the killed people were sealed in the coffin, and they were sent to Poland, and Poland had to sign an agreement that no one coffin will be opened. So there is no access to any materials whatsoever, even today. With maybe one exception of one person that was, his autopsy was done, which may be mentioned later on. So I presented the properties that I used, so any colleague all over the world can repeat my calculations. I'm a human being, so and I'm a scientist, I'm trying to be skeptical about my work as well. And I invited scientists from the committees from Russia and Poland. If they are shy away to show their calculations, they could send me an abstract so I can present my work during the conference in Pasadena this April 15 this year. And they can present their work, and scientists from all over the world can make a judgment who is right or who is wrong. Well, to my surprise, no one sent me one abstract. So I am the only one who is going to present the work in Pasadena. That's how funny it is. Let me show some simulations. The simulation is when we give the computer the model with the rigorous physical behavior of the material and with the initial conditions. Then the computer is calculating step by step, millisecond by millisecond, what will happen. Here you saw the plane cutting through the tree, basically. I will show you a few other simulations of the same type. I would like to point out about this time. It is measured in seconds. Of course, each simulation takes about a week on the supercomputer to calculate the 3 or 2 milliseconds of this event. Okay, so it is very costly in terms of computational calculations. In each case, you will see, of course, some destruction of the edge of the wing, some flying materials from the aluminum from the front edge of the wing. But in each case, the tree is basically cut through within 1/100th of a second, and the plane is flying away. We are talking about velocity of 80 meters per second. It means maybe about twice as long of the room like that within 1 second. And the plane is hitting the 40 centimeters, which is about that much, within quickly about 1/100th of a second. This is, of course, very dynamic event. No one should speculate or use intuition about this event. The crash of the Columbia showed to us that intuition was wrong of all the scientists at NASA who ignored the impact of the material hitting the wing of the shuttle Columbia. They used intuition. They said, well, everything will be okay. It wasn't. Same thinking here. The intuition should not be used. In each case, of course, we can see the same situation. The wing is okay, except the front edge, which is thin aluminum, but so-called beams, longitudinal beams are strong enough to cut through this tree. Now, of course, using this methodology, not only we can answer the question, but we can investigate what are the stresses, what are the times. We can make measurements, physical measurements, that are not possible even in experiment, okay? So this methodology is very powerful, and this is why all these companies that I showed at the very beginning invested millions of dollars to develop this technology, okay? So I'm happy to use it for this particular situation. So we can conclude that based on the parameters provided by the official reports, the model shows that the wing of the 154M plane cuts through the birch for every analysis scenario. Okay? The damage to the wing is localized on the edge, does not deteriorate the lifting surface of the wing, thus should not significantly reduce the ability of the plane to fly. This is contrary, of course, to the Russian and official so-called Miller presentation. Well, but this is not the end of the story. We know, because the satellite picture shows the wings to be this particular wing, which is about 6 meters long, 1/3 of the span of the wing of this airplane, to be found 111 meters from this verge. Well, so something broke this wing, right? That's obviously, I cannot ignore this issue. So the second question is, what is the most probably position of the two 154M airplane at the moment when this 1/3 of the wing will be broken, okay? Well, I look first into evidence. Not being able to go to Smolensk, I had to rely on pictures. Fortunately, there's a lot of pictures available. I can also look into the satellite pictures, and you can see here the path of this airplane. The verge is here. The wing is here. So what you can see, that the left tip, 1/3 of this wing, was broken at this site, we assume, right, by the Russian and official scientists, and flew to the right side of the path of this airplane. Is it possible physically that the left side of the wing, after you break it down, there's no any engine, anything that would fly just by inertia, would fly forward and to the right side of this airplane? Anybody would like to guess?
In Russia it's possible.
In Russia it's absolutely possible, but of course again I will move on the mathematics of this. Okay, the whole thing is available on my internet site, so if you are interested in mathematics, please download my presentation. Of course you can call me. Or come to Ohio. My University of Akron is not far from here. You are welcome to come. I can show you my unique laboratory and we can discuss the details. This particular analysis was done together with Professor Brown, who is distinguished professor in aerodynamics. And you have, visually you can see two events. This wing, before it is separated from the airplane, I'm not showing the whole airplane, just that part of the wing, and the same part of the wing just after you separate from this wing, okay? Those lines are streamlines, the streamlines of the air passing over this wing, okay? If the plane is flying in the normal position, those streamlines are regular. They pass over, they develop lift force, everything is as in the book, the textbook, okay? The moment you separate, you see graphically, and this is calculated using CFX rigorous software, that you create turbulence on the backside of this airplane, of this wing. If you look into pressures distribution, when it is before separation, you have the high pressure only at the edge, front edge of this wing. Of course, the particles hit perpendicular, particles of the air hit perpendicular to the edge, so the pressure is developed. It is a dynamic pressure. Now, at the moment you separate this wing from this airplane, the big high orange pressure distributes over the whole surface area of this airplane. We know that the pressure multiplied by the area is the force. So we created very high force, so-called drag force, that is trying to slow down this part of the wing. This is why the drag that is experienced by this particular part is very important. I will show you some simulation of this event. The plane is invisible, and this moment you have separation. So you see at the beginning, you saw at the beginning the red piece of the wing flying regularly, and then it's trying to kind of randomly or like leave flying in the air. I will show you now the same event from the back side. Okay, it's going together with the airplane, separation, and it's just flying like physics and inertia allows us, aerodynamics would allow it, based on this simulation. And again, from the left side, very quickly, I know I have very little time, but I'm doing this fast. And you have this behavior, which is, in my opinion, very exciting and very important. Well, let me show you how this looks like in three-dimensional space. This is the center of mass of this piece that we were flying and separated. This is the moment of separation. The path, this part of the path is so-called free flow path. Okay? This is the piece that is just flying due to the inertia. Okay? So what we can see that indeed this part is flying in the direction of the airplane and to the right side of the airplane. So not only Russian can create this particular, but physics is in fact allowing this wing to fly forward and to the right. Okay? There's nothing wrong with that. So let's attach this particular free flow curve to the birch. Well, we know that it's 6.5 meters from the ground. So if we hit this with this airplane, this particular position, that curve tells us that it has to hit the ground only 12 meters away, not 111 meters, but only 12 meters away. And it will hit the ground with the velocity 99 of almost 100 kilometers per hour. We are talking about 600 kilograms mass, almost like a car, hitting the ground with 100 kilometers per hour. I would imagine there would be a mark left at that location, right? There's nothing left at that location. So it means that it's not proper to assume that the birch sheared this particular wing. Okay? Those two analyses, the first one that I showed you, and the second one, which are physically, mathematically independent, they are concluding the same thing, that the birch is not the cause of the separation of the part of the wing from the airplane. Well, having that curve, I can do more. I can solve so-called inverse problem. I will attach this particular curve to the location where it was found. I know it was found about 10 meters to the right, so I know where I should attach this curve to. And see where it's supposed to be separated. Well, that point is 70 meters from the birch and 26 meters height above the ground. It happens that that particular height correlates exactly with the work that was done by colleagues in Poland and Professor Kazimierz Nowaczyk. Okay? We work independently, so he was surprised that I calculated the right height according to his analysis, and I was pleased that my analysis is doing what's supposed to be done, because it shows that indeed physics predicted the behavior going to the front and to the right, and also predicted or discovered the location of the crash, the first crash, or first crash, the event of the crash. Well, again, this moment of landing would be with the velocity, because there's more room, more time to slow down that wing, so this velocity is only 43 kilometers per hour. Now, if you look into this picture again, you can see that it was not, that the wing was not gently put in that location. It was crash, it was dynamic crash. Those trees are bent, this is broken. But that damage is correlating with the velocity of 40 kilometers per hour, not with 100 kilometers per hour. So indeed, all events are consistent that we can see with this calculation. Again, let's look into the satellite location. This is the birch. This is the location where I predict this event has happened. Now, if it would happen here, this is a very dark area, so it means they are trees, forest. So if you separate this wing here, this wing not only would have to crawl through the, somehow after hitting the ground, but also cutting through the trees. And a plane indeed should cut through the trees. Because they, according to the Russian trajectory, if this is 6.5 meters, they claim that the plane was flying according to this dash curve. So it means somewhere here, the plane was about 2 meters from the ground. We are talking about Boeing 727, 100 tons airplane, with a 50 meter span of 2 wings, okay? Huge airplane, flying 80 meters per second, 270 kilometers per hour, right? So, at this location, if it has pitched, as they show, most likely the tail would be already going on the ground. And the wheels would be on the ground. So if the plane hits the ground with the wheels or with any part, will not be able to fly up. And especially with losing 1/3 of the wing. Okay, they lost 1/3 of the area that could lift this airplane. Well, here it is, not according to Russian trajectory. You can see it's flying up nicely. Then for some reason it's flying horizontally. It was not enough. They need to lift it up again. It lifted up. And why? Because it has to rotate 180 degrees. If it would rotate here, it will not be able because those wings would be on the ground. Okay? So they said, no, this is not enough. We have to make it bigger. Okay? Now this curve is based on the American sensors in this airplane TAPS. And this shows that the location at this event is 26 meters. So it is according to my calculations. The plane, the trajectory, this trajectory is basically normal, okay? It's not radical. 100 tons airplane without 1/3 of the wing cannot do rapid, lift and slow, and fly horizontal and lift again. Okay, this is not physically possible. Conclusion number 2. The wing fragment cannot separate on the verge and fly over the terrain 111 meters from the tree. From 6 meters high, the fragment would fly only 10 to 12 meters away and would not have enough space to move 10 to 13 meters to the right side. The most probable location of the wing separation is the location at least 26 meters above the ground and 69 meters from the tree, or 42 meters from the location where the fragment was found. I hope I was not boring for you. Thank you.